So the question here is, can both of these products be defined? So let's let A be a matrix that has dimensions of, let's say, n times m, and let's let B be a matrix that has dimensions of m times n. So the only way that you would be able to create the product of A times B is if you had, again, inner dimensions matching. And in that case, you would get, again, because these inner dimensions match, you would get an n by n matrix. And of course, for the B times A matrix, then you would have m times n, and then your A matrix would be n times m. And so these inner dimensions would match, and you would get an m by m matrix. Now, so it is definitely true that A times B and B times A can be defined if you have a very specific case where basically the first dimension here is the last dimension here. So the number of rows you have is the same as the number of columns you have for B, and vice versa. Please note that if you change that, so like let's say for example that you have A as an m by m matrix, and then B is, let's say, an m by p matrix, so that those inner dimensions match, then A times B would be defined, and that would give you an n by p matrix. But B times A, when you look at B times A, you would have m by p and then n by m for your A matrix, and that would not be defined. So it's not that every single product is going to be defined when you have A and B. It has to be that it's a very specific structure of n times m, m times n. So number of rows is the same as number of columns. Number of columns in A is the same as the number of rows in B.